Hello and welcome to this video that covers the Physics and Maths Tutor Geometric Series question set 1, and we're going to cover questions 1 to 5. So the first question, the adult population of a town is 25,000 at the end of year 1. A model predicts that the adult population will increase by 3% each year, forming a geometric sequence. Show that the predicted adult population at the end of year 2 is 25,750. So from here we know that the initial value is going to be 25,000. If it increases by 3% per year, we can use the fact that finding a percentage increase of 3% and any increase is 1.03, because this is the same as 103%. So 0.03, one way that we can find to go from a percentage to a decimal is to do 103 divided by 100, which is 1.03. So what we do is we get our initial year 1 value and times that by 1.03, and in the calculator that will give you 25,750. Write down the common ratio of a geometric sequence. So the common ratio is a number that you multiply each time you want to increase a term. So to see the general form here, the first term is a, second term is ar, third term is ar squared. Each time you're multiplying by r. So here, each time you're increasing by 3%. So your common term here, the number that you're going to multiply, is 1.03. So r is 1.03. The model predicts that year n will be the first year in which the adult population of a town exceeds 40,000. Show that n-1 log 1.03 is greater than log 1.6. So to start off with this question, we need to set up our general form of our geometric sequence. This is going to be the nth term is equal to a, which is the first term, just say the nth term, the nth value, where n is the terms. First term is a, and then we're going to have r n minus 1, where n is the value, so r is the common ratio. So it tells us that we want it to exceed 40,000, so we're going to plug in 40,000 as our nth value, and that's equal to a, our first term, which is 25,000, r, which is 1.03, and then we have n minus 1. Now we can see that both sides have log base 10, so let's convert this into log base 10. So it's going to be log base 10 of 40,000 is equal to log base 10 of 25,000 plus, or we could put it all together actually, so log base 10 of 25,000, 1.03, n minus 1. From here, what I'm going to do is I'm going to expand this using my log rule of log a plus log b equals log ab. So it's log base 10 of 40,000 equals log base 10 25,000 plus log base 10 of 1.03 n to the power of n minus 1. I'm then going to move log base 25,000 to the other side. So I'm going to subtract both sides, and that gives me log base 10 of 1.03 n minus 1. And then I'm going to use the log rule, which is log a minus log b equals log a over b. So this is going to be log base 10 of 40,000 over 25,000. And on the same line on the right hand side, I'm going to use the log rule of log a to the power of b is equal to b log a. So that gives me equal to n minus 1 log base 10 of 1.03. If I do 40,000 over 25,000 on the calculator, you get 1.6. So this is log 1.6. Again, I'm going to get rid of log base 10 because log base 10 is equal to log. That's equal to n minus 1 log 1.03. So that gives us part of it, but then it wants us when it exceeds 40,000. So actually we want here, we want our answer to be greater, this part here wants to be greater than 1.6. So because this is equivalent to 40,000, so it's log base n, n minus 1 log base 10, 1.03 greater than log 1.6, because this value represents our eventual result for 40,000 if we were to do it. So through here, in reality, 40,000 is less than this, so less than, less than, less than, less than, less than, and then if we swap each side over, then we get n minus 1 log 1.03 is greater than log 1.6. So yeah, I mean, you can change the signs all the way through once you say equals. A lot of people like starting from equals and changing it, or you could have started from the greater than or less than if you'd written it this way around. But that's how you get your answer. The next part is find the value of n. So to find the value of n here, it's n minus 1 log 1.03 greater than log 1.6. Divide both sides by log 1.03 to get n minus 1 log 1.6 over log 1.03 and then plus 1. So n is greater than log 1.6 over log 1.03. Plugging that into the calculator, we get log base 10 1.6 over log base 10 1.03, and then we're going to plus 1. So that's going to be n is greater than 16.9. But it says that predicts the year n will be the first year in which it reaches. So here the first year will actually be n is equal to 17. That's the first year of when the population will be greater than 40,000. So it's not n is greater than 16.9, it's n equals 17. So just be careful of the question. At the end of each year, each member of the adult population will give £1 to a charity fund. Assuming the population model, find the total amount that will be given to the charity fund for 10 years from the end of year 1 to the end of year 10, giving the answer to the nearest 1,000. So essentially, each adult population will give £1. So that means that, for example, at the end of year 1, it's 25,000. So year 1 will give 25,000. Year 2 will give altogether 25,750. So in total, we want to find out, we're going to sum those answers to get our results for when n is greater than, so when n equals 10. So to do that, what we will do is we are going to just use our formula for the sum. So if we go here, the sum of a value is equal to a 1 minus rn divided by 1 minus r. So we want to find the sum up to year 10, and that's equal to a, which is 25,000, bracket 1 minus 1.03 power 10 divided through by 1 minus r, so 1 minus 1.03. Plugging that into your calculator, will give you the result of 200 so it's equal to 286,596.98. But here it says to the nearest thousand, so in reality we're going to round this number here. So it's going to be 287 because of the 5 rounds the 7 up, so £287,000. So again, we just use the basic sum from our formula book. Sn, sum of the values, is equal to A 1 minus Rn divided by 1 minus R. Question 2. A car was purchased for £18,000 on the 1st of January. On the 1st of January the following year, the value of the car is 80% of its value in the 1st of January the previous year. Show that the value of the car exactly 3 years after its purchase is 9,216. So again, the general formula, so the nth value is equal to the nth value is equal to the A R n minus 1. So here A, the first value is 18,000, n is equal to 3, and it's 80, the value of the car is 80% of its value. So this means that it's gone from 100% to 80%. So that means that it's now gone to 0.8 of its previous value. So R is equal to 0.8 here. So R equals 0.8. So our sum is going to be equal to 18,000 times 0.8 to the power of exactly 3 years after it's done. So here we've got to be careful because this is actually n equals 1. N equals 2 is after the first year, so 1 year after. N equals 2 is after the second year, and n equals 3 is after the third year. 1, 2, 3. So show the value of the car exactly. So year 1, year 2, and then year 2 is going to be 3, and year 3 is going to be 4. So here n is equal to 4 in this case. It's not straightforward, so I'll just repeat through what I've done. So here n equals 1, 1st of January of the first year, n equals 2 is 1 year after, n equals 3 is 2 years after, and n equals 4 is 3 years after. So therefore it's 4, and this is going to be to the power 3 because it's n minus 1. Plugging that into the calculator gives a value of 9,260. The value of the car falls below 1,000 for the first time n years after it was purchased. So find the value of n. So here again, the nth value is equal to A R n minus 1. So the nth value here is 1,000. So if it's below 1,000, that means A R n minus 1 is less than 1,000. Plugging in our values is going to be equal to 18,000 times 0.8 to the power of n minus 1, less than 1,000. Divide through by 18,000, so we get 0.8. n minus 1 is less than 1,000 over 18,000. And then from here, we can take it from here, so we could do log base 10, so it's 0.8 n minus 1 equals log, and then 1,000 divided by 18,000 is equal to 1 over 18. Then we use the log rule, so the log rule of log AB is equal to B log A to bring n minus 1 to the front. So n minus 1 log 0.8 is less than log 1 over 18. Then I'm going to divide through by log 18, so it's n minus 1 equals log 1 over 18 over log 0.8. And then our final answer, so n itself is equal to log 1 over 18 over log 0.8 plus 1. So plugging that into our equation, so log base 10 of 1 over 18 divided by log base 10, 0.8 plus 1 gives an answer of n is equal to 13.95. But here we've got to be careful because our first value is n equals 1 is actually when the time is 0. So the question is looking for n years after it was purchased. So if year 1 is year 0 and n2 is year 1, that means we need to subtract 1 from here. So we do 13.95 minus 1 to get n equals 12.95, which gives us a 13 years after the car is bought. As the first one. So this one's a bit more confusing because we start from n equals 1 as the starting point of buying the car, and 1 year afterwards is n equals 2. So to find the value, so to find how many years afterwards it be, we have to take 1 away from here because this is measuring, this includes the first year of the car that you bought. N equals 1 is not 1 year afterwards, it's at the starting point. So you have to subtract 1 to find how many years afterwards you bought the car. An insurance company has a scheme to cover the maintenance of the car. The cost is £200 for the first year, and for every following year the total cost increases by 12%, so that for the third year the cost of the scheme is £250.88p. Find the cost of the scheme for the fifth year. So for this one, we are going to use the value. So again, this is a geometric sequence. So the cost, so in year 1, A is equal to 200, that's the first value. This is increasing by 12%, so this is an increase of 1.12 every time. So R is equal to 1.12. And then we're going to go forward and try. So the cost of the scheme is the nth value is equal to ARN minus 1. And then we're going to go through and find our value. So that's equal to 200, 1.12 for the fifth year. So n equals 5. So it's 5 minus 1. So it's 200, 1.12 to the power of 4, which is equal to £314. And 200. So to the nearest penny, this is going to be £314.70p. Find the total cost of the insurance scheme for the first 15 years. So we go to the total for geometric series, which is Sn equals A, 1 minus Rn over 1 minus R. And we're going to plug in our values. So Sn, so it's A, 1 minus Rn divided by 1 minus R. So the insurance scheme is A is equal to 1.12. R is equal to, A is equal to 200. R is equal to 1.12 and N equals 15. So the sum up to 15 is equal to 200, 1 minus 1.12 to the power of 15 divided by 1 minus 1.12. Plug in those values into the calculator at 200, 1 minus 1.12 to the power of 15 divided by 1 minus 1.12, and we get a very large value of 7,455.94p. Question 3, the third term of the geometric sequence is 324 and the sixth term is 96. Show that the common ratio of this sequence is 2 over 3. So here we have, so the third term, so essentially you could say U3 for example is equal, so UN is equal to, or the nth term is equal to A Rn minus 1. So here the third term is equal to AR3 minus 1, and the sixth term is equal to AR6 minus 1. And we know that this is equal to 324, and this one is equal to 96. So if we can find the difference between them, we can say, well, 96 over 324 is equal to AR squared over AR to the power of 5. Actually, no, sorry, the other way around. So 300, so we've got 96, so that's going to be AR to the power of 5 divided by AR squared. Cancelling this down, A divided by A, so cancels, and 96 divided by 324 is equal to 8 over 27. R to the power of 5 divided by R squared is equal to R cubed. 5 minus 2 is 3, and then the cube root of 8 over 27 is equal to R. So plugging those values into a calculator gives a value of R equals 2 over 3 as required. Finding the first term of the sequence. So to find the first term, all we need to do is just plug in one of the values. So if we start with the first one, so it's 324 is equal to A 2 over 3 to the power of 3 minus 1 is 2. So what we do here is just we say this is the same as 324 divided by 2 over 3 all squared is equal to A. So 324 divided by 2 over 3 squared is equal to 729. And find the sum of the first 15 terms. So Sn, again, straight to the formula sheet, say to geometric sequences, and A 1 minus Rn over 1 minus R. And if n equals 15, A equals 729, and R equals 2 over 3. S of 15 is equal to 729, 1 minus 2 over 3 to the power of 15, divided through by 1 minus 2 over 3. Plugging that into the calculator, get a value of 2,182, which is your answer for part C. Part D, find the sum to infinity of the sequence. So it's a geometric sequence. So we can find the sum to infinity, particularly when R is less than 1. And we can use the formula here, the sum to infinity equals A divided by 1 minus R. So A is equal to 729 divided by 1 minus 2 over 3 is equal to 2,187. And that's your final value for this one for part D. Question 4. The first three terms of the geometric sequence are k plus 4k and 2k minus 15. Show that k squared minus 7k minus 60 is equal to 0. So from here, so we know that the first term that we have, term 1, is A is equal to k plus 4, because that's the first term of the sequence. Then we know that AR, so we times by the common ratio, is equal to k, and AR squared is equal to 2k minus 15. So from here, we can find that R is equal to AR over A, which is equal to k over k plus 4. Because A over A, so that's equal to R. And from here, we can then substitute into one of our values. So we could have R equals k over k plus 4 we also know that r is equal to AR squared over AR. So that's going to equal 2k minus 15 divided by k. And from here, we can say that, well, we have k over k plus 4 is equal to 2k minus 15 over k. Multiplying both sides by k gives k squared over k plus 4 equals 2k minus 15. And multiplying both sides by k plus 4 is k squared equals k plus 4, 2k minus 15. Multiplying this out is k times k squared, 2k is 2k squared, 2k plus 4 is 8k, k times minus 15 is minus 15k, and 4 times minus 15 is minus 60. Moving k squared, so minusing k squared on both sides, is 0 equals k squared. 8 minus 15 is minus 7k, and then we've got minus 60. So this is as required for part A. Hence show that k equals 12. So from here we can solve it. So you could use your calculator here directly to solve this one, or you could factorize. So you could say that k minus 12, k plus 5 is equal to 0. So k equals 12 or k equals minus 5. But as k is greater than 0, therefore k is equal to 12. And this is not a correct answer here. And there you've shown for part B. To find what the common ratio is, we said that r is equal to k over k plus 4. So that's equal to 12 over 16, which is equal to 3 over 4. And to find the sum to infinity, the sum to infinity is equal to, and again, straight to your formula sheet, a over 1 minus r. There's a over 1 minus r. So for this one, a is equal to k plus 4, which is equal to 16, as k is equal to 12. So therefore, the sum to infinity is equal to 16 divided by 1 minus 3 over 4. Plugging that into the calculator equals 64. Last question, question 5. A geometric sequence has its first term 5 and the common ratio 4 over 5. So we know that a is equal to 5 and r equals 4 over 5. And find the 20th term of the sequence to 3 decimal places. So the nth term is equal to AR to the power of n minus 1. A is 5, we've already got A and R, and we know n is equal to 20. So the 20th term is equal to 5 times 4 over 5 to the power of 20 minus 1. Plugging that into your calculator is 5 times 4 over 5 to the power of 19. And we get a value, so once it's at 3 decimal places, so it's going to be 0.072 as your answer. Question 2, find the sum to infinity. Sum to infinity, straight to your formula book, it's a over 1 minus r. So here a is equal to 5, r is 4 over 5. So plugging that straight into the calculator, 5 over 1 minus 4 over 5 is equal to 25, and that's the sum of a series to infinity. Given the sum to k terms is greater than 24.95, show that k is greater than log 0.002 over log 0.008. So we know that the sum to infinity, sum Sn, is equal to a 1 minus Rn over 1 minus r. We know that the sum is greater than 24.95, so 24.95 is greater than, and we know a to be 5, 1 minus 4 over 5, and this time we want the sum to k terms, so Sn is actually Sk, So it's going to be k to the power of k divided by 1 minus 4 over 5. So the first step here is multiply both sides by, so 1 minus 4 over 5 is just equal to a fifth. So we're going to times both sides by a fifth, so 24.95 times 1 over 5 is greater than 5, 1 minus 4 over 5 to the power of k. Expanding this out to 24.95 times a fifth is equal to 4.99. So 4.99 is greater than 5, 1 minus 4 over 5 to the power of k. Then I'm going to divide this actually by 5 to get rid of the 5 here. So it's 4.99 divided by 5 is equal to 0.998 is greater than 1 minus 4 over 5 to the power of k. And then what I'm going to do is going to swap these round. So I'm going to add 4 over 5 to the right hand side and subtract 0.998 on both sides. So from here I'm going to get 4 over 5k is greater than 0.002. Taking logs on both sides because we've got a power here that we want to get rid of. So taking logs is 4 over 5k greater than 0.002, and this is going to be to a log. We use the log rule, log a b to the power of b is equal to b log a. So it's going to be k log 4 over 5 is greater than log 0.002. Check that briefly just to check your answer. So we just want it to be greater than that one, so k is greater than log 0.002 over log 0.8. Checking your answer, that's all it asks for, so we can leave the answer here. And then find the smallest possible value of k. So put in your answer in here. So we've got k is greater than log 0.002 over log 0.8. So k is greater than, so log base 10 of 0.002 divided by log base 10 of 0.8 is equal to k is greater than 27.85, but k has to be, so given that's k, so k terms apply, it means that k has to be an integer, you can't have a part of a term. So k, the smallest possible value is k is equal to 28. And that's questions 1 to 5 of the geometric series.